Okay, so we're asked to find the cross products of two vectors. So the question says, find the cross product of u, which is 3, minus 2, 1, and v, which is minus 3, 3, and 1. Then show that u cross v is orthogonal to both u and v. So we're going to write this using a matrix. So u cross v. So we're going to put this as I, j, and k. So we have 3, minus 2, and 1. And then we have minus 3, 3, and 1. Now the next thing I'm going to do is rewrite these. So for I'm going to be looking at j and k. So I'm going to write minus 2 and 1, 3 and 1. So j, this is going to be I and k. So I am going to use 3 and minus 3, 1 and 1. And for k, let me just move that, make it easier to see. So let's put it right here. And then k, we will use I and j. So it's going to be 3, minus 2, and 3. Now we need to do I minus j plus k. So we've done the discriminant before. So we're going to look at using the diagonal method. And we're going to write these. So first of all, so we're going to multiply by I. So we're going to write 2 multiplied by, so we've got minus 2 times 1, so that's minus 2. And it's going to be minus and 3 times 1, which is 3. And this is multiplied by I. And then we've got a minus, so we do the same to the next one. So we have 3 times 1 is 3. Minus 3 times 1 is minus 3, so it's minus 3. And this is multiplied j. And then we're going to have a plus for k. 3 times 3 is 9. Minus 3 times minus 2. So we've got minus, and this is going to be plus 6. And this is multiplied by k. So we're just going to simplify. So minus 3, minus 2, minus 3. This is going to be minus 5, and so that's minus 5i. So minus, and we've got 3 plus 3, which is 6, so it's going to be minus 6j. And then we've got a plus, but we've got 9 minus 6, which is 3, so that's plus 3, so plus 3k. Now we're going to write this in component form. So this is going to be minus 5, minus 6, and 3. So this is component form. Okay, so the next thing we do is we want to show, so we need to show that u cross v is orthogonal to u and to v. So u times v, so u cross with, sorry, u cross v multiplied with u. So we're going to do that first. So I'm going to substitute in the values. So we've got what we just worked out. So we've got minus 5, minus 6, and 3 multiplied by u, which in the question we were given. So that's 3 minus 2 and 1. So 3 minus 2 and 1. So we're looking for this to equal 0 to show that it is orthogonal. So minus 5 times 3 is minus 15. Minus 6 times minus 2 is plus 12, so plus 12. And we've got 3 times 1 is 3. So minus 15 plus 15, that is 0. So far so good. Now u cross v multiplied by v. So this is going to be minus 5 minus 6, 3 multiplied by v. And the question, it says minus 3, 3 and 1. So we need to multiply. So minus 3 times minus 3 is plus 15. So minus 6 times 3 is going to be minus 18. And 3 times 1 is 3. So we have 15 minus 18 plus 3. So this is 0. So both vectors are orthogonal. So both vectors, so let's say both dot products. So both dot products equal to 0. So both vectors are orthogonal. And if we were to